Hey, welcome to the shop. It's a different part of the shop. I'm over here by the milling machine today, and I have a pretty exciting project that I've been putting off for a long time, and that's building a tray to hold my most commonly used tooling and get organized over here. Let me give you some of the backstory and the plan for the day. So I bought this mill and the lathe that's over next to it a little over a year ago as an upgrade from the Harbor Freight mill and lathe that I used for 7 or 8 years. I liked those machines, but wanted something just a little bit more stout, and these are definitely serving the purpose. I've had so many people ask about the mill and lathe as they've seen them in the background of my videos, and also wanting to see some more machining here on the channel. A major part of the reason I haven't used these more is that I never really organized my tooling. I have, wrenches and things laying here in the chip tray. They're all covered in oil and chips, and that's just a pain. I've got most of my tooling down in the base underneath. There's a cabinet that swings open. So I'm gonna pick out my most commonly used tools, lay them out here, design this up in CAD, and then cut it out of plywood on the xTool CO2 laser. Now, you might have seen this on a video a few videos back where I used it to make a sheet metal forming tool. And in this video, I'm gonna use that same 1/4 inch thick plywood that I used there, but 2 different layers so that I can have both through holes and recessed pockets for shadow boards. All right, so I need to get my tooling here. These wrenches are all pretty important, so I'm gonna pull them out. I'll pull this collet out of the spindle. I don't know, probably a chip brush isn't a bad idea. We'll see if that fits. Pull out some parallels for the vise. Here, definitely the drill chuck. My shell mill for facing things. Probably a few of my most common end mills I'll put in there. Maybe a small machinist square if it fits. So I think I have it narrowed down to the items that are really essential. The point isn't to have more here, it's to have less, but have the right stuff. So I put a board down on the Siegmund table so I don't ding any of this stuff up while I'm working on it. I think I'm gonna put the shell mill and the chuck down through a hole over on this side. Then on this side, I'm gonna put some holes for my most common 4 collets. Not too bad for my little shop. What do you think? Pretty good layout? So I started drawing this up in CAD, and for regular round holes and rectangular pockets, it's pretty easy to measure with calipers and get that just right. However, for more odd-shaped items like the wrenches and the brush, it's a little harder, so I had to come up with a better way to do that. So I have this old scanner that I don't mind throwing some greasy tools in, and that works a little better than taking a photograph because you don't have that lens distortion that you get when you take a photo of things. So this works pretty well. I'll scan it into the computer here, and then I can process the shape in some free software. Let me show you how I do that. So this software is called Inkscape. It's free, you can download it off the internet, and it's a vector drawing software. And you typically need a vector file which defines the actual image's curves, and you need that to work with in CAD. So I can use what's called a trace of a bitmap, so that takes that scanned image and turns it into a vector file. I need to clean it up a little bit because there are some blips, and I offset it to give a little bit of margin around, and saved in a file format I can import into my CAD system. I'm using Fusion 360 for the CAD today, and I'm pretty happy with the design after I moved some things around. So I need to rough cut a piece to be able to fit down inside the bed. I'm cutting this off at about 13 inches. It's 24 wide, so that should leave a little margin and be okay to fit right inside the laser. I need to clear some room by the garage door to exhaust the laser cutter outside and remove those fumes, so I might as well clear the way the fun way. I built this vintage cart from scratch. You'll see that build video coming out in a couple weeks. So I've rolled the laser over here by the door, and there's a hose right out the back. The fume extraction blower is integrated right into the machine, which is a really nice feature on this. It's different from my first laser cutter where I had a separate blower that I had to use. Okay, I'm gonna take that plywood that I rough cut right here, just 1/4 inch plywood, and throw it in the laser cutter. Okay, so I just brought my laptop right over here to the machine. One of the cool features about the P2 is it actually connects to Wi-Fi, so I don't need to have my computer right here connected at all. I could do this from a desk, but it'll be nice to just be right here close. So another cool feature is the built-in camera. So I can see my workpiece. It has 2 cameras, so I can capture a close view over here. I can't believe what I did. So I had in my mind the bed size as the maximum, but the working area is a little bit smaller than that. So I think I made my image a little bit too big. I'm gonna need to make a few adjustments just to make this whole thing fit. Yeah, so upon further review, it looks like it's gonna clear by 50 thousandths of an inch. I need to come down a little and to the left. Okay, we are doing some work envelope testing here. I did not mean to do that. So rather than cutting right through, I have it set to just score the material and make a light mark to be able to get a good visual on how everything's laying in. I think I needed to be just a little further to the left. The actual close alignment camera doesn't go all the way to the left of the bed, so when I'm using this much room, I need to exercise a little caution, but this should be a good way to get a visual. Let's see how it turns out. How cool is that? Up top, you can see that wrench going in okay. It's working. All right, well that worked pretty good. It looks like my positioning was off just a little bit. You know, that camera is kind of hard to use when you're pushing it right to the very limits, but it worked pretty well for me before when I was doing smaller parts. But right here, I'm seriously pushed right up to the maximum size. I'm super glad that worked out though. So I'm gonna shift it over just a little bit and then make my final cuts. Because those score marks were slightly off, I decided to flip that piece over and cut through it for the bottom of the tray rather than the top. So that's what we're gonna cut now. Okay, I'll hit that magic button. Ooh, and it's off to the races. So maybe you can hear that air compressor going. That's another really cool feature on this, is it has a built-in compressor to actually blow the smoke out of the way of the nozzle as it cuts. In my first laser cutter, there's an old video on my channel with my first laser cutter. It didn't do that. I actually had a separate air compressor that I would run with that. When we come around over here, you can see it's getting those circles cut out, making its way around the border. It got a slot there for that square to stick through. Then over here, I've got the holes cut for the drill chuck and shell mill. So it's going pretty well. Barely made it, but it did it. It did it. Right there. There it is. All right, well, it cut pretty clean for the most part. There's one hole here in this corner that didn't quite make it through. So I don't know if once you get up into the top extremes, if I need to address the beam alignment, maybe something like that. But overall, cut pretty good. Let's cut out the top. Notice that's generating quite a bit of smoke there. If you look out the back, you can see it's all getting drawn out. It's pretty effective. Outside the garage, it smells a bit like a Burger King, but in here, it's going okay. I think I just figured out the issue with the hole that didn't cut out in the upper corner. It's actually because the material isn't perfectly flat. It's bowed up a little bit, so it was sitting a little bit higher, and that pushed things out of focus, I think. So it came with some little clamps to clamp the wood down to the slats. That should correct the issue. With the smaller parts I was working on before, I didn't really need to do that. So I guess live and learn, but yeah, I think if it was clamped down, it probably would go a little better. I could just visually see that on this cut. Oh, that's looking pretty good. Pretty good. You can see how we were clear down on the very edge of the cutting envelope. I mean, clear down to the bottom of the slats there. Up here, that's where things are a little off on that last one. And look at this. See how I can press that down? So I think that's the issue. I could see how the wood was closer to the actual nozzle. So I needed to clamp that down, and I don't think I'd have these kind of problems. That's something I should probably test out. Let's pull it out and see how it fits. I'm just using some screws in the corners here to align everything. The through holes seem to line up pretty well. So let's start by checking those. Here I have the drill chuck, and that sits in there nicely. And then right above that, I'm gonna have the shell cutter here. That fits pretty well too. All right, yeah, I'm liking it. I guess I'll lay it down and see how all the flat stuff fits, huh? Yeah, first shot. Look at that. Love it. It's fab time. Let's go ahead and fabricate a little bracket to be able to hold this up and keep everything in place. Man, I'm pumped about this. It is looking so good. Before I start fabricating, I'm just gonna shoot some dark paint on the top and then some blue paint on the bottom for the pockets. Let that dry while I work. So I'm fabricating the frame out of some 1" or 25mm square tubing that's 16 gauge or 1.5 millimeters thick. I'm using this because I keep a good stock of this material around. It's kind of my go-to for building small carts and frames like this, which I've done several of. So I get all the pieces cut together just to make myself a kit. I'm going to put a rectangular border around this and then just have 2 legs coming off to mount it to the wall. I've decided to TIG weld this, so I'm cleaning up each of the edges to be able to lay that in nicely without any contamination. I could MIG weld it and I wouldn't need to clean it up, but then I'd want to grind down my welds to make sure they were flush. So it'll save time overall just to TIG weld it where I can lay the welds in flush to begin with and I won't have to do much grinding. So I'm laying everything out here on the Siegmund table and I'm just putting 2 sets of stops in to give me a square reference for the first corner. The key from what I've found to making rectangular frames and having them turn out well is to have one good solid reference square in the beginning, and you can see those grid lines help to verify that on the corner. And then as long as the pieces are all cut right, everything should slide right into place. I like to measure along the way to see that everything's fitting in, and then I clamp everything down securely, and after everything's held securely, I'll go ahead and measure one more time and check for square. And that centerpiece is going to act as a support that I'll put in a minute. Well, I'm going to go ahead and weld this out. I'm starting on the outside corners. They pull the least generally and help keep everything from twisting when I weld the faces. Next, I'll weld the face from the inside out. In all reality, this tubing's pretty thin, and having it clamped to such a large table probably wouldn't matter a whole lot what order I welded things in as long as it was fixtured while I did. And I let it cool for a minute, but I'll follow this practice anyway. Just working my way around, I dip my tungsten there, it happens, and I'll just carry on. Alright, with this side welded, I'll just flip it over. I sunk those welds in nice and tight, so I wouldn't need to weld it or use any shims when I flip it over. So that's a bit of a time savings. That's kind of the trade-off with MIG versus TIG, is with MIG, it's a lot harder to sink them in and lay them really flat on a frame like this. Sometimes you want some reinforcement, but sometimes that flat profile can be really nice. Now with all of these faces welded, I am going to tack on a couple of brackets to mount it to the wall. I'm just using those fireball squares there to hold them in place and put one single tack on it. After welding it out, I painted it and did a little assembly here. You can see that center support as well as 4 tabs in the middle to hold it together with some fasteners. This has me thinking about all sorts of different ideas to make some different trays like this for my toolbox and other areas in the shop. Thanks a ton for tuning in. If you learned something or enjoyed this video, let me know by hitting that thumbs up, and we'll see you next time.